Guys, please confirm to me. All of you are getting my voice on screen. Those are attending in online. Guys, please confirm to me. All of you are getting my voice on screen. Those who are attending in online. Guys, please confirm to me. All of you are getting my voice on screen. Guys, please confirm to me. All of you are getting my voice on screen. Those are attending in online. You రాలేదేంటి? Guys, please confirm to me. All of you are getting my voice on screen. Guys, please confirm to me. All of you are getting my voice on screen. Those who are attending in online. Right. Right. Good afternoon, guys. And check it what we completed in the last session. All right, sir. Then I think we completed totally operators part. We completed totally tokens topic here. We completed totally. All right. Now, after understanding the tokens, the next topic in language fundamentals is like what there data types. What is the next topic there? No, data types. That is the next concept. Try to understand it. Data types is the next topic. So what exactly the data type? What is the purpose of these data types now? All right, sir. Now, first of all, understand some definitions. No, I'm giving some definitions to you. Try to understand it. For example, if any programming language, observe carefully, if any programming language is able to represent data as per data types, if any programming language is able to deal data with respect to the data types or is able to represent data as per the data types, then the type of programming language is a typed programming language. The type of programming language is what there? Typed programming language. Come again, what is the definition I've given there? If any programming language is able to represent data as per data types, then the type of programming language or then that programming language is typed programming language. So data is represented as per the types. Okay, there are two types of typed programming languages. There are two types of typed programming languages. What are the two types of typed programming languages? No, first one is statically typed programming languages, and second one is dynamically typed programming languages. There are the two types now. Statically typed programming languages, and second one is what they are, dynamically typed programming languages. What exactly the meaning of statically typed programming languages, and what is the meaning of dynamically typed programming languages? First, observe carefully the very first one. No? Statically typed programming languages are what? Observe carefully. These programming languages are able to represent data after confirming its type. First, data type must be confirmed. After that only data must be represented. These programming languages are able to represent data after confirming its type. Right? Examples: C, C++, Java, and so on. So many examples are available. All these are like what is statically typed. First, type must be confirmed. After that only data must be provided. Some example I'm telling to you. Observe carefully. See, in statically typed programming languages, int I is equal to 10 we provided. Here 10 is a data, but type is what there, int. So I is a variable. It is able to represent the 10 data. First, type must be confirmed. Data type is confirmed. Type is confirmed. After that only data will be represented. Got it or not? This is one example. Another example I'm telling to you. Observe carefully. Int I semicolon. I is equal to 10. Still it is valid. Int I is equal to semicolon. I is equal to 10. Still it is valid. How can you say that? First, I variable type is what? Int. I variable type is what? Int. And its data is what there? 10. I variable type is what there? Int. And its type is what there? 10. That we are able to provide. Right, so now this is clearly the point here what I'm telling to you. Observe carefully. Right. After completion of this, there are the two examples that I'm telling to you. For our understanding purpose, I'm giving there. Next one is, what is this dynamically typed programming language? Dynamically typed programming languages. What is its meaning actually? These programming languages are able to represent data, that means are able to confirm the type of data after representing data. Understand the difference now? These programming languages are representing data, are able to represent data after confirming its type. All right, so now here what I'm telling there, these programming languages are able to confirm the type of data after representing data. Have you got the difference now? Please try to check the difference again. Represented data after confirming its type. But here confirming type after the data. Understand it? Nothing is the difference. No, now the point is what there in the statically typed programming languages. In statically typed programming languages. In statically typed programming languages. First type, then data. First type, then data. In dynamically typed programming languages, first data, then type. Got or not? Say for example, in the case of examples I'm telling there, observe carefully. Python is the best example. Python is what their best example. In the case of Python, how it is going on there, I is equal to, in the case of Python, we are able to represent I is equal to 10. After that, print off type of I. First data is represented. After that only type we are able to represent. First what is represented here? Data. Then after that type is going to be represented. Got it or not? So now here we are able to get the type is what there? Integer. Int type here we are able to get. Got it or not? So this is a clear-cut information here we can understand. In a dynamically typed programming languages, first data, then a type. In a statically typed programming languages, first type, then a data. Got the difference now? Right, sir. Then after that, observe carefully. Next one now. In statically typed programming languages, in statically typed programming languages, in statically typed programming languages, before representing data, first we have to confirm it's a type. First we have to confirm which type of data we are representing. First we have to confirm its type. Here to represent type, here to represent type, we have to use data types. Understand my point? In statically typed programming languages, first we have to confirm its type before representing data. So here to represent type of data, here to represent type of data, to represent type of data, we have to use what their data types. This is what exactly the meaning of what their data types. All right. How many types of data types are existed actually? How many types of data types are existed here? If you observe this, right, sir. All right, sir. Data we have to use what their data types. All right, sir. What are the various data types are existed here? What exactly the data types are existed here? If you observe this point, no, answer is very clear. Now try to recognize this. To prepare Java applications, Java has provided the following data types. What are the various data types are provided here? I'm giving some classification. Try to understand it now. First one is primitive data types or primary data types. Primitive data types or primary data types. And the second one is user defined data types or secondary data types. Under this user defined data types or secondary data types, what types are available actually? Examples we can understand now. All arrays, all classes, abstract classes, interfaces, and so on. All these are come under what their user defined data types. Under this primitive data types, again, how many types are existed here? If you observe this, two types are available. What are the two types now? Numeric data types and second one is non-numeric data types. Numeric data types, and second one is what they're non-numeric data types. Under this non-numeric data types, what data types are available there? Char, and other one is like what they're Boolean. These are come under what they're non-numeric data types. Under this numeric data types, again, types are available. What are the various types under this? First one is integer or integral data types. Integer or integral data types. And the second one is non-integral data types. And the second one is what they're non-integral data types. Under this non-integral data types, what data types are available here? Float, double. Two types are available. Under this integral or integer data types, no, four data types are existed here. What are the four data types? No, first one is a byte, second one is a short, next one is a int, after that long. These are overall data types. Right. Now this is the total classification here we have to understand. Tell me once again what exactly the classification is available over the data types. No, initially data types are divided into two types. What are the two types? No, primitive data types, and second one is what they're user defined data types. Observe carefully. Under these primitive data types, again two types are available. What are the two types? No, numeric data types and the non-numeric data types. Under these numeric data types, again two types are existed: integer or integral data types, and second one is what they're non-integral data types. Under this integral data types, four data types are available: byte, short, int, long. Under this non-integral data type, no, float, double. Under this non-numeric data types, no, char, boolean. Under this like user defined data types, no, all arrays, then all classes, abstract classes, interfaces, and so on. These many things are existed here. All right, sir. First of all, I want to give sizes for each and every data type. For byte, 1 byte of memory. For byte, how much memory there? 1 byte of memory. For short, 2 bytes of memory. For integer, 4 bytes of memory. For long, 8 bytes of memory. For float, 4 bytes of memory. For double, 8 bytes of memory. Okay. For character, 2 bytes of memory. For boolean, 1 bit, not even byte. Right. Now these are the data types. Then what we are having clearly. For each and every data type, that exactly sizes can I provided. But what about this user defined data types? No. Not I'm giving. Try to understand this. No. Memory sizes for the user defined data types is not fixed. That is depending on the members. That's depending on the number of members which are declared in the user defined data types. Say for example, if we take an array, an array, how much is the size for the array? Any clarity for you? How much is the size for array? Any clarity for it? For example, 5 elements are available, integer. 5 into 4, 20 bytes of memory. That is a rough calculation. Maybe that array may have 4 or maybe more than 4. We don't know. At the time, we are not having any fixed memory size now. That is totally depending on what the number of elements which are declared. 1 minute. Right, sir. That is totally depending on the number of members which are declared in the respective type. Say, for example, class I have taken. String is a class. What is the fixed memory for the string object? No fixed memory. Depending on the number of characters, what are included inside the string. Double quotation ABC is available. 3 characters, roughly 6 bytes of memory. 3 into 2 bytes of memory, 6 bytes of memory. In that way, we can calculate it now, but we don't have any clear cut. We don't have any separate fixed memory for the user defined data types. That's okay. Now this is completed, that we can understand here. Got it or not? Then after that, after completion of this, another point is like what I'm telling there. After completion of this, right? Next one is default values for each and every data type. For byte 0, for short 0, for int 0, for long 0, for float 0.0f, for long 0l, okay, for double 0.0 like d, or either we can use small d or we can use capital D, or no prefix, no suffix, no problem here. All right, now for character, observe carefully. Default value is a single space. Default value is what there? Single space. All right, for boolean, the default value is what there? False. For boolean, the default value is what there? False. Everybody understand this now. For boolean, the default value is what there? False. Right, sir. So user defined data types, secondary data type. Then what is the default value for each and every user defined data types now? Observe carefully. The default value for the user defined data types is null. The default value for user defined data types is what there? Null. How, sir? How can you say this? String str semicolon. Default value will come. What is the default value for str now? Str is equal to null. Null value will come to the default value. Say for example, I have a class A. For this, I am creating object a small a semicolon. Then what is the value for a here now? Value for a is what there? Null. By default, null value is available. So the default value for all the user defined data types is what there? Is a null value. Got it or not? The default value for all the user defined data types is what there? Null value here we can understand. All right, sir. Next one is after that, after completion of this particular one. All right, sir. Now these are the points here we can understand now. So this is totally the default value and memory sizes for each and every data type. That point here we understood. Next one is after that, after giving that total classification, what advantages we are able to get from data types now? What advantages here we are able to get from the data types now? That we have to understand. Answer for this question is very clear. Try to understand it now. In Java applications, data types are able to provide, in Java applications, data types are able to provide the following advantages. What are the various advantages here? First one is, observe carefully. See, I'm asking this question to you, try to answer for it first of all. Here my question is, int a is equal to 10. For a variable, how much memory will be allocated? How much memory will be allocated for a variable? 4 bytes of memory. How can you say 4 bytes of memory? For a variable, 4 bytes of memory will be allocated. How can you say like 4 bytes of memory? Into data type on the base of the data type only. So that's the very first point here. What is the first point here? No. All right. Data types. Data types are able to define memory sizes for the data. Data types are able to define memory sizes for the data. Are able to provide memory sizes for the data. That is one point here. Second one, after that. Now I'm asking one more question. Now try to answer for it now. Byte B is equal to byte B is equal to 150. I want to use. Is it possible? Byte B is equal to 150. Is it possible? No, it is not possible. Why it is not possible here? Why it is not possible? Byte variables are having some ranges. Range values are available. Minus 128 to plus 127 is the range values for byte variable. Minus 128 to plus 127. It is a range value for the byte variable. So what is the second advantage here? We are able to say data types are able to define values range for the variables. Values range for the variables. All right. Now these are the two things here we can understand. Range values there. But memory sizes already here we provided in the diagram. Whatever the diagram I have taken there, memory sizes here we provided clearly. That's okay. But now here we are calculating what their range values here we have to calculate. Got it or not? So now also carefully to calculate range values for all the range values for the data types. To calculate range values for the data types. Range values for the data types. We have to use the following formula. Right, understand it. To calculate range values for all the data types, we have to use the following formula. What is this formula here? We have to use there minus 2 power n minus 1 to 2 power n minus 1 minus 1. Observe carefully. To calculate range values for the data types, we have to use the following formula. Minus 2 power n minus 1 to 2 power n minus 1 minus 1. Where n is what there? Where n is a number of bits, not bytes. Where n is what there? Number of bits. Right or not? Say for example, I want to take an example. There we can calculate it. No. Example is what there? Byte to data type. Byte to data type. For byte, what is the size actually? Size for byte is what there? 1 byte. 1 byte is equal to how many bits there? 8 bits. How many bits there? 8 bits. Right, sir. This is clearly information here we can understand 8 bits. Apply this one in the form like here, no? Minus 2 power 8 minus 1 to 2 power 8 minus 1 minus 1. So calculate it. What's the value here we are able to get there? Minus 2 power 7 to 2 power 7 minus 1. Minus 2 power 7 is what there? Minus 128 to 128 minus 1. Minus 128 to 127. This is the way to calculate what the range values for each and every data type. But there is a point here actually. There is a problem now. What is the problem here? Observe carefully. The above formula is valid up to the integral data types. It is not valid for the remaining data types. The above formula is valid up to the integral data types and it is not valid for the remaining data types. Observe carefully. Alright, sir. It's valid up to the integral data type, not valid for the other data type. But my requirement is for other data types also. For other data types also, I want to calculate min value and max value now. For other data types also, I want to calculate what their min value and max value. Then how it is possible then? Right. For that, Java has given a solution. All right, sir. To get min value, that means minimum value, that means range in the sense min value and max value. To get min value and max value for each and every data type, to get min value and max value for each and every data type, Java has provided the following constant variables from all the wrapper classes. To get min value and max value for each and every data type, Java has provided the following constant variables from all the wrapper classes. That's clear? What exactly this one? What are the constants here? Min underscore value and max underscore value. They're the two constants. First of all, what is this wrapper class actually? All right, sir. From the wrapper classes, these things are available here. But first of all, what is this wrapper class actually? Wrapper classes are the classes representation of all the primitive data types. For each and every primitive data type, a separate class type is available. The separate classes were there, wrapper class. Understand my point clearly? Wrapper class are the classes representation of all the primitive data types. For each and every primitive data type, a separate class is defined by Java. That class of primitive data type, the class representation of the primitive data type, that class is what their wrapper class now. Now let's see this one. Now here, examples I'm telling there, observe carefully. First of all, what are these primitive data types actually? Byte, short, int, long, float, double, char, boolean. These are like what their primitive data types. For each and every primitive data type, a separate wrapper class is available in java.lang package. That is what there java.lang.byte is the class type. B is capital. All classes names must be started with what there uppercase letters. Next one is a short. For short, java.lang.short. For int, java.lang.integer. Not int, integer class is available. For long, java.lang.long. For float, java.lang.float. For double, java.lang.double. For character, for char, java.lang.character. Not char, class name is what there, character. For boolean, java.lang.boolean. That's it. So these are overall primitive data types and the respective wrapper classes types. How many number of primitive data types are available? 8 number of primitive data types are available. For each and every one, how many number of wrapper classes are available? 8 number of wrapper classes are available. But understand one point here, I'm telling there. Min value and max value, min value and max value constants are not existed in which class there? Boolean class. See, Boolean values are what they're true and false. Where what is minimum value and what is maximum value? Is there any meaning for it? In between true and false, we are unable to say one value is a minimum and another value is a max here. No, so there is no particular content. Leave this one. That is one point here. Next one is what there after that. All right, sir. Min value and max value are existed in the character class, but they are able to display space as a min value and a question mark as a max value. That means it's a meaningless. Even for characters also, we cannot say one is minimum, another one is a maximum. We don't have any such kind of things in the case of these characters now. Right? Minimum value is what their space it is providing, max value is what their question mark is providing. It means that unsupported symbols now. For characters, which one is minimum and which one is maximum? How can we decide that? So for Boolean also, no concept like min value and max value. For character also not available. But in the case of this Boolean, constants are not available. In the case of this character, constants are available, but they are providing single space as a min value and question mark as what their max value. That's this is about like what the content given. After that, now let me show one example for each and every data type, minimum value and max value. We want to calculate. Now try to understand this. Let me open the program here. Right, sir. Class test. Public static void main string array args. Inside this sys.out.println. Of course, here we have to use what there sys.out.println of. There I want to display the data. First of all, I want to show byte dot min value byte dot max value. Similarly, in all cases here I want to provide this is like what the short dot min value, short dot max value. Integer dot min value, integer dot max value. Long dot min value, long dot max value. Float dot min value, float dot max value. Double dot min value, double dot max value. Character dot min value, character dot max value. Then after this character, boolean dot min value, boolean dot max value. But anyway, when we call boolean dot min value, boolean dot max value, there we are able to get some compilation error. Observe carefully, test.java, Right, sir. You know, here in the case of this boolean dot min value, boolean dot max value, there we are able to get a compilation error. Why? Because min value and max values are not existed inside what their boolean class. So there definitely we are able to get a compilation error. Java C space tester dot Java. Now here we are getting some error. Cannot find the symbol min value from boolean class. Max value from which class? No, boolean class. No. Leave it. So this I want to make it as a comment. Here we are able to get some error. Leave this one. Alright, sir. In all the remaining cases, constants are available, but in the case of character, min value is what there is single space, max value is what there question mark. It is provided. Now let me check this. Java C space tester.java compiled successfully. Java space test. Values we are getting. Observe this character. Min value is what there space, max value is what there question mark. In all the remaining cases here we are getting, but these float and double values are having like what are exponential values. Exponential values in the form of u only they're able to represent. No need to think much about it. In all the remaining cases here we are getting there. Alright, so now I want to copy this. That's it. Of course, this is an output here. Right, program is existed like this. So this is overall information about like what their min value and max value and the related content, data types, and its related content here we understood. The total like data types topic here we understood. Clear? Next one is after that, after completion of this data types part here, right son. Next topic is like what there typecasting. Right sir. Before understanding this typecasting, let's have a look on this total data types. No, observe carefully. What points can I discuss here about these data types? No, total. What exactly the points can I given there? Now try to understand it. No. First of all, what is typed programming language? What we are understanding that about the typed programming language? If any programming language is dealing the data with its types, if any programming language is able to represent data as per its type, then that programming language is what their typed programming language. How many types of typed programming languages are available? Two types of typed programming languages. What are the two types now? Statically typed programming languages, and second one is what they're dynamically typed programming languages. What is this statically typed programming languages now? These programming languages are able to represent data after confirming its type. First type, then data. C, C++, Java. In statically typed programming languages, first type, then data. Next one is dynamically typed programming languages. These programming languages are able to confirm the type of data of representing data. In a dynamically typed programming languages, first data, then a type. Example is what there? Python. I given some example. I is equal to 10, print a type of 5. In statically typed programming languages, before representing data, first we have to confirm it's a type. Here to represent type of data, we have to use what their data types now. All right, sir. To prepare Java applications, Java has provided following data types. What are the various data types? No. First of all, initially, two types of data types are available: primitive data types and user-defined data types. Under primitive data types, again, two types are available: numeric data types and non-numeric data types. Under numeric data types, again, two types are available: integral data types, non-integral data types. Under integral data types, only four types of data types are available. What are the four types now? Byte, short, int, long. Under non-integral data types, two types are available. What are the two types now? Float and double. Under non-numeric data types, two types are available. What are the two types now? Char and boolean. Under user-defined data types now, all arrays, all classes, all abstract classes and interfaces are come under what their user-defined data types now. That's okay, fine. Memory size for each and every data type here, what we are able to understand. For byte, 1 byte of memory. For short, 2 bytes of memory. For int, 4 bytes of memory. For long, 8 bytes of memory. Right, for float, 4 bytes of memory. For double, 8 bytes of memory. For character, 2 bytes of memory. For boolean, 1 bit here we are getting. Right or not? Right, so then default values are available for each and every data type. No, what are the default values here? Byte, short, int, long, 0 is the default value. For long, 0L, of course. For non-integral data types, for float 0.0f, For double it is what there 0.0. For character, single space is a default value. For boolean, false is the default value. Right. So then after that, memory sizes for the user-defined data types are not fixed. That is totally depending on the number of members which are declared in the user-defined data type. The default value for user-defined data type is what there null. In Java applications, data types are able to provide the following two advantages. What are the various advantages? Data types are able to provide memory sizes for the data. Memory sizes, integer requires 4 bytes of memory, float is required 4 bytes of memory, long is required 8 bytes of memory. So that is totally depending on what their sizes, that means data types only. So data types are able to provide memory sizes for the data. Next one, data types are able to define values range for the variables. For each and every variable, some values range, minimum value and max value range will be calculated. To calculate range values for the data types, we have to use the following formula. What is this formula here? We have to use there minus 2 power n minus 1 to 2 power n minus 1 minus 1, where n is the number of bits. Example byte we have taken. So one size is equal to 1 byte. That is what there 8 bits. Minus 2 power 8 minus 1 to 2 power 8 minus 1 minus 1. That is minus 2 power 7 to 2 to power 7 minus 1. Minus 128 to 127. The above formula is valid up to the integral data types. It is not valid for the remaining data types. But to get min value and max value for each and every data type, Java has provided the following constant variables from the wrapper classes: min value and max value. Right, sir. Wrapper class are the classes representation of the primitive data types. For each and every primitive data type, a separate wrapper class type is provided. Byte java.lang.byte, short java.lang.short, int java.lang.integer, long java.lang.long, float java.lang.float, double java.lang.double, char java.lang.character, boolean java.lang.boolean. Min value and max value constants do not exist in a boolean class. Min value and max value exist in the character class, but they are able to display space as min value and question mark as a max value. Then after that, I shown one program there to display like what there min values and max values and their respective output also here we provided. So this is overall data types what we discussed clearly. Right or not? Right. Sir. Next one is what is this typecasting actually? What is the meaning of this typecasting? Very simple. The process of converting data from right. Sir. 1 minute. Right. The process of converting data from one data type to another data type is called typecasting. The process of converting data from one data type to another data type, that is what they're typecasting. Right, sir. How many types of typecastings are existed actually? There are two types of typecastings are existed there. What are the two types of typecastings are existed now? First one is like what there, observe carefully, primitive data types typecasting, and second one is right user defined data types typecasting. Observe carefully. There are two types of typecastings. What are the two types of typecastings now? First one is what there, primitive data types typecasting. Second one is user defined data types typecasting. Right. So there are two types of typecastings: primitive data types typecasting, user defined data types typecasting. Nice. But what is this primitive data types typecasting now? What's the meaning of this primitive data types typecasting? Observe carefully. The process of converting data. The process of converting data from one primitive data type to another primitive data type is called primitive data types typecasting. The process of converting data from one primitive data type to another primitive data type is called what there? Primitive data types typecasting. Observe carefully. Right, sir. Then what about this user-defined data type typecasting? User-defined data type typecasting is what there? Observe carefully. The similar definition, but from converting from one user-defined data type to another user-defined data type. The process of converting data from one user-defined data type to another user-defined data type is called user-defined data types typecasting. Observe carefully. To perform this user-defined data type typecasting, we require either inheritance, that means either extends relation or implements relation between two user-defined data types. User-defined data types are what they classes or interfaces, something else. No? Observe carefully. To perform user-defined data types to typecasting, we need either extends relation or implements relation between two user-defined data types. To perform user-defined data types typecasting, we need either extends relation or implements relation between two user-defined data types. Because of this reason, I will cover this topic. As part of the object orientation. At the end of the object orientation, their inheritance topic will come there. Part of the inheritance, we will discuss about this user-defined data types typecasting. All right. Now, meanwhile, we have to understand what there at present primitive data type typecasting. Observe carefully. How many types of primitive data types typecastings are existed actually? There are two types of primitive data types typecastings. What are the two types? Can know? First one is implicit typecasting. Second one is what there? Explicit typecasting. First one is what there? Implicit typecasting. Second one is what there? Explicit typecasting. All right, now here we have to understand what is this implicit typecasting and what is the meaning of this total implicit typecasting part here. Observe carefully. What is this implicit typecasting? The process of converting data from lower data type to higher data type. The process of converting data from lower data type to higher data type is called implicit typecasting. Is called what there? Implicit typecasting. The process of converting data from lower data type to higher data type is called what there? Implicit typecasting. All right, sir. Then how we are able to perform implicit typecasting? How it is possible to perform implicit typecasting? Observe carefully. To cover all possible cases of implicit typecasting, Java has given a chart. Java has given a predefined chart. Java has given a predefined chart. What exactly the predefined chart was provided here? To cover all possible cases of implicit typecasting, Java has given a predefined chart. What is the chart was provided by Java? Observe carefully. byte to short, short to int, int to long, long to float, float to double. Okay. Now, okay, this is like what their char to int. That's it. Now, this is exactly like what their all possibilities of typecastings. Byte to short, short to int, int to long, long to float, float to double, char to int. Answer my point here. So this chart is giving all possible cases of what their typecasting. Which typecasting? You know, implicit typecasting. Got it or not? See, the conversions are not on the base of sizes. Which data type is lower data type and which data type is higher data type? That is totally depending on like what their this chart only, not on the base of sizes. Here sizes, if you take consideration, no, you will get wrong output. I'm giving there. This chart is provided by Java predefinedly, but observe carefully. Byte required 1 byte of memory, short required 2 bytes of memory, int takes what there 4 bytes of memory, long will take 8 bytes of memory. Now float is taking what there 4 bytes of memory, double is taking what there 8 bytes of memory, and character is taking 2 bytes of memory. Character is taking how many bytes of memory there? 2 bytes of memory. Observe carefully. If we think in the point of sizes now, if we think in the form of sizes now, how it is possible from long to float? No? But here, if we compare long and float now, float is a higher data type when compared with the long. Long is lower data type when compared with what there float. All of you observe carefully. So long is like what the lower data type and float is what their higher data type. Observe carefully. So not on the base of sizes, but on the base of what we can define which one is a higher and which one is lower. No, on the base of the how much more data we stored in the data type, how much less data we stored in the data type, how much less data and how much more data. On the base of that only we are able to define which data type is higher, which data type is lower. Before that, remember one more point. Each and every data type is having its own internal data representation. Each and every data type is having its own internal data representation. Separate data representation is available internally. Understand it now. So byte is having its own representation, short is having its own representation like this. As per their internal data adjustment, as per the internal data arrangement, long data type is taking less data when compared with the float, even though long is having 8 bytes of memory and float is having 4 bytes of memory. Float is able to store more data when compared with the long. Even float is taking 4 bytes of memory, less memory, and the long is having 8 bytes of memory, more memory. Got my point or not? So that is totally depending on what their internal data, internal like data arrangement. As per the internal data representation only, how much data is going to be stored more in the respective data type, how much data will be stored less in the respective data type. On the basis of that only, the chart was prepared by Java. Between long and float, if you observe this, long is lower data type and float is what their higher data type. That we have to remember clearly. Got it or not? All right, sir. That's okay, fine. Now again, after completion of this, how we are able to perform this implicit typecasting? Okay, chart is okay, but programmatically, if you want to perform implicit typecasting, then what we have to do? How it is possible to perform implicit typecasting? No. Right, observe carefully. To perform implicit typecasting, we have to assign lower data type variable to higher data type variable. Come on guys, now what I'm telling there, to assign, we have to assign lower data type, we have to assign a lower data type variable to a higher data type variable. To perform implicit typecasting, we have to assign a lower data type variable to a higher data type variable. Got it or not? Right, sir. Example I'm telling to you, observe carefully. Byte b is equal to 10, int I is equal to b. Now tell me which variable we assign to which variable? Which variable we assign to which variable? Now tell me. B variable we assign to int variable. B variable is what there? Byte job. I variable is what there? Int job. B variable we assign to what there? Int variable. That means lower data type variable is assigned to higher variable or not? Lower data type variable is assigned to what there? Higher variable. Understand it clearly. So this is what exactly that assignment here we have done. When we assign like this, internally typecasting is going to be performed. So here, whatever it may be. In this case, what is compiler responsibility and what is JVM responsibility in this case now? Now just I'm explaining the content here. Now try to understand here. In this particular scenario, compiler responsibility is different. What is compiler responsibility? When we compile this program, first compiler will recognize right side variable data type and a left side variable data type. Compiler will recognize right side variable data type and left side variable data type. If right side variable data type is compatible with left side variable data type, no error. If right side variable data type is not compatible with the left side variable data type, no, definitely there is an error here we are able to get. All of you get my point or not? So what's the point I'm telling there? First of all, compiler will check right side variable data type and left side variable data type. Compiler will check whether right side variable data type is compatible with the left side variable data type or not. If right side variable data type is compatible with the left side variable data type, no, compiler will not raise any error. If right side variable data type is not compatible with left side variable data type, no, definitely compiler will raise an error. But how can you decide which data type is compatible with which data type? No, which data type is compatible with which data type? No, how can you decide that? Where answer is very clear. Always lower data types are compatible with the higher data types, but higher data types are not compatible with the lower data types. So we can assign lower data type variables to higher data type variables. We cannot assign higher data type variables to lower data type variables. Get my point or not? So because of that reason, now here in this case, right side variable data type is what their byte job. Left side variable data type is what their int job. Byte and int, if we compare, byte is lower than int. So we can assign byte variable to int variable. So we are able to assign what their byte variable to int variable. That is possible here in the case of what their Java. Okay, in this example, no compilation error. That's okay. Compilation is completed. But remember this: compiler responsibility is only type checking. Compiler responsibility is only what their type checking, not type casting. But who will perform typecasting in Java? JVM will perform typecasting. Compiler is checking only types. Right side variable data type is compatible with the left side variable data type or not. That's a type checking only could be done by compiler. But who is performing typecasting? No, JVM is performing typecasting. When we execute the same in a section, JVM will perform two actions. First one is JVM will convert right side variable data type to left side variable data type. After that, JVM will copy the value from right side variable to left side variable. JVM will perform two things. Typecasting. Type will be converted to left side. That means right side type is converted to left side. After that, JVM will copy the value from right side variable to left side variable. JVM will copy the value from right side variable to left side variable. So this is what exactly the meaning of like what there typecasting, that what compiler is able to do and what JVM is able to do now. They're the points here. Here we have to understand clearly now, right? So okay, then that related points I'll discuss with you in the next class now. So when is the next class for this content here? Then tomorrow and day of tomorrow our schedules are very much fixed, right? Almost 4 o'clock to 8 o'clock or 8:30, like that. I need to take some more extra sessions there. Continuation of this topic will come on Monday. Continuation of these topics will come on what date? Monday, right? Observe carefully. Right. Now take some break and come back for 6 o'clock class. There we'll discuss about object orientation. Right, sir. Thank you.